All right, so we're going to talk about writing equations for parallel lines today. And we just talked about that lines that are parallel don't ever touch each other. And we also said parallel lines have what kind of slope? Parallel lines have the same slope. So we're looking for lines that have the same slope, or if they're asking us to write an equation, it has to have the same slope. So before we write some equations, we're going to look at this example and just decide if the lines are parallel or not. So this is what that last sticky is for, and your three pretty colors of markers. So we have three lines on there. Our first line, line A, goes through the points -4, 3, and 1, 2. Then we've got a line that goes through -3, 0, 1, -1. And then line C goes through -3, 4, and 2, and -5. So sometimes when we look at the picture, it might be easy to tell right away if they're parallel or not. The ones that are in your homework look very similar to this, where there's three lines on there, but it's kind of tricky because the picture is a little bit small, so you want to make sure we actually calculate it before making the decision. So you always want to double check yourself. Plus, just in case the graph isn't drawn exactly to scale, we always want to do the math to make sure. We don't want to just look at the picture to make the decision. So I'll give you a second to copy this graph down. So you want to use your three different color markers to draw yourself a picture of a graph. Line A should be one color, line B should be another color, line C should be your first color. Okay, so now for us to figure out if these lines are parallel, we need to find our slopes for each of these lines. So before we go in and do that, remember your slope formula is m equals y1 minus y2 over x1 minus x2. So we're going to do that for each line, and then we're just going to compare and see which ones actually have the same slope. So the first one, we want to use our color that we picked. Go ahead.
Oh, why is there a y to the bottom?
Oh, yeah, it should be next. Good catch. That's X2. So now I'm going to use my first color, and let's find the slope of line A. And in order for us to do that, we want to use the 2 points that they gave us, that -4, 3, and the 1, 2, and we just want to find the slope. So I see that my first y value is 3 minus my second y value, which is 2, over my first x value minus my second x value. And when I do that, 3 minus 2 gives me 1. -4 minus 1 gives me -5. So my slope here is just -1/5. So I want to see if I end up getting -1/5 for any of the other slopes to decide if line A is parallel to line B or line C. So now I'm going to take my next color, my line B color, and I want to find my slope for line B. So I'm doing my first y value, which is 0, minus -1 over -3 minus 1. When I have minus a negative, so when I have 0 minus -1, those two negatives make a positive, so I really have 0 plus 1 here over -3 minus 1, which gives me 1 over -4. Are those lines parallel? No, their slopes are different, right? And we could kind of see that even when we looked at the graph. It didn't look like they were exactly the same. They didn't have exactly the same slope. It kind of looks like line B is getting closer to the line A as we look to the left side of the graph. So let's just check line C now. And line C, if I'm finding my slope for line C, I'm going to do -4 minus -5 over -3 minus 2. -4 plus 5 gives me 1. -3 minus 2 gives me -5. So we can say that line A and line C are parallel because they have the same slopes. So line A and line C are parallel lines because they have the same slope. So your first couple of questions today are going to ask you just to decide if the lines are parallel. So when they do that, you're just finding the slope, seeing if they are the same. And then the last couple of questions are going to ask you to actually write equations of parallel lines. So like we were writing equations for perpendicular, we were writing equations in point slope form, and we were writing equations in slope intercept form. Kind of the same idea, except for now we're going to write them for parallel lines. So now when we go to write equations for parallel lines, they're going to say things like write an equation of a line that passes through 5, -4, and is parallel to the line y equals 2x plus 3. So they're normally going to give you a line equation, and they're going to give you some other kind of point that they want the parallel line to go through. So in order for us to do this, we need 1, the slope, 2, plug in the point. So now, since they gave me a point and they didn't give me the y-intercept, I'm going to use the formula y minus y1 equals mx minus x1, because it just makes our life easier since they didn't give us the intercept. So we want to use our point intercept. We could our point slope form. We could use our y-intercept form, but it's going to give us more work to do because we're going to have to plug in and we're going to have to solve for the intercept, and there's just a whole lot of extra steps. So that's why we like this formula a little bit better. So if we know that we want to be parallel to the line y equals 2x plus 3, we know that we want to have the same slope as 2x plus 3, and we know from earlier in the year that the slope of this equation is what? 2. So even though they didn't specifically say, oh, the slope of the parallel line is 2, they told us an equation. We can look at the equation and pick out the slope. So we know our slope is going to be 2, and then we just want to use the point that they gave us, which was 5, -4, and we're going to plug this in for our x1 and our y1. So our final equation is going to end up being y minus a -4, which makes it positive, equals my slope, which is 2, x minus 5. So it's the same thing we were doing 2 classes ago. Only difference is they're not just saying find a slope, plug in a point. They're giving us a line and asking it to be parallel. So we have to remember that parallel lines have the same slope and then plug in. We could also give you 2 equations of lines and ask you to decide if they were parallel. So before, the first example gave us pictures of graphs. We found the slopes from the graphs. Here they're just giving us 2 equations of lines. They're saying determine if the lines y equals 4x squared, or 4x plus 2, and x plus 4y equals 3 are parallel. So in order for us to determine if y equals 4x plus 2 is parallel to x plus 4y equals 3, we just need to know the slopes of both of those equations. The first one is easy for us to look at and pick out the slope because it's in slope-intercept form. We can see that slope right in front of the x value. So we can see that the slope of the first one is right there. We see that it's 4. But when we look at the second equation, that's in standard form. So we need to get y to be all by itself there. So we have to rearrange that equation. We have to dust off our skills from back solving equations. And we have to rearrange it and get y all by itself. So the first thing we want to do there is subtract x on both sides. So then I end up with 4y equals negative x plus 3. And I know that I can't combine a 3 and a minus x because they're not like terms. And I also know that when I'm writing an equation for a line, I like my x to come before my number, so that's why I just wrote it negative x plus 3 instead of 3 minus x. And then the last thing I have to do is get rid of that 4 that's in front of the y. So I have to divide by 4. I have to divide by 4. When I do that, I get y equals. And now when I divide x plus 3 by 4, I can divide both of them by 4 because I want to know what that number is for my slope. And I know if there's not a coefficient in front of my x, that it's really a 1. So this is the same thing as saying negative 1/4 x plus 3/4. So my slope here is 1/4. Slope of my other line is 4. Can I say they're parallel? No, they don't have the same slope. These lines are not parallel. Since slopes are different. So I think that's the trickiest type of equation because you have to rearrange it in order to figure out what the slope is.